Welcome to Math Minders Academy. If this is your first time joining our channel, we urge you to smash the subscribe button so that you will become part of our family. Hit the notification bell icon so each time we produce a new video, you'll be among the first to receive it. Share this video, go to the comment section at the end of today's tutorial and share what you learned with us. So today we are going to look at curve sketching, and we are going to be concentrating on cubic function. We are going to learn how to sketch cubic function. So at the end of today's tutorial, you'll be able to sketch any given cubic function. We are going to itemize and discuss in full all the necessary steps required for you to completely and accurately sketch any given cubic function. And so we are going to look at a specific cubic function. But first, let's look at all the steps involved in sketching a cubic function. The first step is you have to find the x-intercept, that is the root of this cubic function. Then after that, we are going to look at the y-intercept, and this occurs where s is 0. The y-intercepts allow us to see where the curve cuts through the y-axis. And then we are going to find the turning point. Being a cubic function, we're expected to have 2 turning points, one minimum, one maximum. Then when these points are assembled together, we'll use a smooth curve to connect all of this, and then we obtain the pattern of our function. Okay, and so today we are going to look at the function f of s equals s cubed minus 11s squared plus 24s. So if we have this function and we are expected to sketch this, what are the requirements? Just like we have highlighted before, the necessary step required. So first, we are going to look at the x-intercept. Of course, the x-intercept occurs where f of s equals 0. All right, so this occurs where f of s equals 0, and this means that we are going to set our function s cubed minus 11s squared plus 24x. Okay, we set it to 0. So here, when we factor out, we are going to have s outside, and then we have x squared minus 11x plus 24 equals 0. So now we look at the bracket. What we have inside the bracket is a quadratic expression. So when we separate these two brackets, we are going to have, it's either s equals 0 or s squared minus 11x plus 24 equals 0. Okay, so we obtain this, and now when we solve this factorization, when we factorize the quadratic part, we are going to obtain 2 linear factors. All right, so here we are going to have x equals 0, or here when we factorize this, believing that we all have done factorization, and if you have not, you check out our video, on factorization of quadratic expression, you will learn steps required to fully factorize an expression or the quadratic expression. So here, when we factorize, we are going to obtain x minus 8 for this, and then x minus 3 equals 0, okay? So here, when we solve each of these, we will get s equals 0, or solving this, we have s minus 8 equals 0, or here we have s minus 3 equals 0. And then this will further give us s equals 0, or s equals 8, or s equals 3, okay? So now, these are the 3 points on the x-axis where this curve is going to pass through. Of course, now we will also obtain the y values by substituting each of these s values into our original function. So we are going to find f of 0, f of 8, and f of 3. And of course, you do this, you will be able to get the point. So here, we are going to get the roots of the equation we have seen where this happens. And so when we plot the point on the x-axis, we will get these 3 points, which gives us the roots. So these are the 3 points. We have 0, where s is 0, which is the origin. We have where s is 3, and of course, if you check the value of y is going to be 0, when you substitute 3 into the original function, you are going to obtain 0 for y. And of course, here on the x-axis, you know that the value of y is 0 on the x-axis. That is y is 0, and whereas on the y-axis, the value of s is 0. And so now the 3rd point is where s is 8 and y is 0. So we have all of this plotted out, And then what else do we need? We said we need the y-intercept, and this happens when we make s 0, okay? When we make s 0, we are going to get the y-intercept. And so let's look at this. If we make s 0 here, all right, and so if we look at f of 0, it's going to give us 0 cubed, all right? And then minus 11 times 0 squared, then plus 24 times 0, right? Everything here is going to give us 0. Okay, so the y-intercept is going to be the point 0, 0, okay? Occurs where s is 0, and then we have obtained the value of y to also be 0. So that's the origin. It's also it's actually collided with one of the roots of the equation. So the curve is expected to pass through the origin. And then we are going to look at the turning point. The turning point, and we say here we are going to use the differentiation to obtain the turning point. And so what we do, we look at our original equation, which we can set out this way: y equals s cubed minus 11x squared plus 24s. Okay, and so here we want to look at dy ds. We want to differentiate. This power here will come down. We have 3. We reduce this 3 by 1, so it gives us 2. If you also have challenge in differentiation of simple algebraic expressions, you can also check our channel for a video on differentiation, so you'll get all the details, all the necessary steps required to differentiate simple algebraic expression. So here, we'll multiply the coefficient of s by 3, which is the power of this, the highest power of this function. So, and that gives us 3 here, and then we reduce this power by 1, that's 3 minus 1 gives us 2. Then, the second term, we multiply again, the coefficient of s squared is 11, we multiply by 2, that gives us 22, and we reduce the power by 1, so we obtain this. And then here, if you also do the same thing, this is 24s to power 1. If you multiply, we have this. Okay, and of course, if you reduce the power by 1, you have s to power 0, which is 1. So here we obtain 24 times 1, which is 24. So now what we do is to set dy ds to 0. Of course, the reason is dy ds measures the gradient of the function at turning point. It measures the slope of the function at turning point. And at turning point, if you drop a tangent at turning point, the tangent will be parallel to the s-axis and the slope will be 0. So that is why we are setting dy ds to 0 here. So that means we are going to have 3s squared minus 22x plus 24 equals 0, okay? Now, again, we factorize here, of course, believing that we've mastered the art of factorization. You can, of course, use any other method to solve this. We need to find the values of s. So here, if we factorize, we are going to have, if you look at it, if you multiply 3 and 24 here, okay, if you multiply this 3 here and this 24 here, you get 72, all right? And so if you look for the factors of 72, whose sum will give you, minus 22, we are going to use here, for us to get that, we are going to use 18 or minus 18 and minus 4 to achieve that. All right. So like we said, if we are using minus 18 and minus 4, because the product gives us 72. 72 is obtained when we use 3, which is the coefficient of s squared, to multiply the constant 24, gets 72. So we are looking at two factors of 72 whose sum is minus 22. So we are using minus 18 and minus 4. So we can rewrite this as 3s squared, okay, minus 18x minus 4x plus 24 equals 0. So here we can have 3x into x minus 6. Here we have minus 4 into x minus 6 equals 0, okay? Now, solving, we are going to have, if we come up here, and then factor this out, s minus 6 is common. And then here we have 3x minus 4 equals 0. So solving each of the brackets, it means s minus 6 equals 0, or 3x minus 4 equals 0. So here we obtain s equals 6, or if we solve this, we are going to get s equals 4/3 or 1.3, okay? So we have this, of course. So this will be the turning point. Of course, it's not completely a point. So what we are saying is that the turning point is going to occur where s is 6, and then there's going to be a certain value of y. Again, where s is 1.3, and then there's going to be a certain value of y. And so how do you get these values of y? We can check f of 6. So you can go back to our original function y equals x cubed minus 11s squared plus 24s. Insert 6 for s. So substitute s equals 6 here, and you are going to obtain minus 36 for this. So y is going to be minus 36 for this. And then if you also insert 1.3 here into the original cubic function, you are going to obtain 4.8. You're going to obtain 4.8. So here we have 4.8. Okay, so these are the 2 points that serve as our turning point. All right, so what we do when we obtain this is to show the turning point. So we drop our this, and then we can see the two green circles there represent the turning point. Of course, one is going to be a minimum and one is going to be a maximum. The one above, which has the greatest value of y, the one that has the value of y as 4.8 is going to be the maximum. And then the one that has minus 36 as the value of y is going to be the minimum. So we have the minimum and the maximum. So we've been able to obtain the turning point. And then what is left? We are going to now draw our curve to connect all of these points that we have, plotted on our system. So we have all the necessary points already showing. So we are going to use a smooth curve to connect all of this. The curve will now represent our cubic function. So you can see the curve connecting through all the points. And bear in mind that this curve is defined within a domain where s is -1 and 9. So we are just seeing part of the cubic function. So we have defined our domain where we have all possible values of s that define this cubic function. So we are just taking it from where s is -1 to where s is 9. And what we see on our screen is a good representation of the cubic function whose graph we have successfully sketched. So guys, this is how you carry out the sketching of any cubic function given to you. Extend these steps to any cubic function, you'll be able to obtain the curve. You'll be able to sketch the curve. If you find value in today's tutorial and you are yet to subscribe to our channel to become part of our family, we urge you to smash the subscribe button, hit the notification bell icon so that each time we have a new video, you'll be among the first to receive it. If you love our video, go to the comment section and tell us what you have learned from today's tutorial. Is there any area you want us to improve upon? Let us know. And if there's any topic you also want us to work on, develop a video on that topic, go to the comment section, tell us about this. We urge you to share this video so that the YouTube algorithm will be able to show this video to many more other students who may need it to prepare for their various examinations. We want to also see you with us in our next class where we'll be discussing another interesting maths topic. Till then, this is Maths Minders Academy saying goodbye for now.
In the midnight glow where the stars align, we lose ourselves in the rhythm divine. Underneath the sky painted with dreams, we're chasing the echoes of silent screams.